Hello, I'm Patty Simpson with Simpson Math. In this video, we're going to use the properties of logarithms to help us to expand those logarithms. So first we have these three rules or properties. The quotient rule says that when we have two numbers in the argument that are being divided, that we can take the log of the numerator and subtract the log of the denominator. When we have the log of argument where they're multiplying, we have the product of two numbers, we can take the log of the first one plus the log of the second one. That's the product rule. And the power rule says that when we have the log of a number being raised to a power, that we can multiply that exponent times this one. That we can just multiply the power times that log. So we're going to use those to help us expand our logarithms. Here's an example. I have log base 6 of xy. Notice in my argument, I have two numbers that are multiplying together. So I can use that product rule to say log base 6 of x plus log base 6 of y. I have expanded this logarithm using those rules. Here's another example. I have log base 6 of 6x. Again, I have a product in there. So I have log base 6 of 6 plus log base 6 of x. Notice in this case, I can actually evaluate this. I know that 6 to the first power equals 6. So this is just a fancy way of saying 1. I can go ahead and evaluate that and simplify it to be 1 plus the log base 6 of x. I can't simplify this one because I don't know what x is, so I don't know what that number is. So I can simplify it down to here. But again, I used my product rule to help me to expand that logarithm. Another example, we have log base 6 of x divided by y. This time, I'm going to use my quotient rule because I have a quotient inside my, or two things dividing inside my argument. I take the log of the top and I subtract the log of the denominator, which makes sense because when I have a y in the denominator, remember if you think about the exponent on the y that brings it down to the denominator, it's equal to a negative exponent. So it makes sense then that we are subtracting so that we end up with a negative exponent. Then let's use that again, and this time let's do log base 6 of x over 6. So a log of my numerator minus the log of my denominator. Here I can simplify this again to say that that is 1. Let's use the power rule so that we have log base 6 of x squared. In this case, I can use the power rule. I can make this 2 kick out front or just multiply times this log base 6 of x in my argument. Here I have log base 6 of 6x squared. I'm going to use two rules on this one. The first one I see is a product. These two things are multiplying together. So I'm going to use my product rule as I did there. So that I have log base 6 of 6 plus, so the first one plus the second one, log base 6 of x squared. Now in this case, I can do a couple of things. Here I had my x squared, and I know that that's equal to where I use my power rule so that I end up with 2 log base 6 of x. But then I also can evaluate that so that the log base 6 of 6 is just equal to 1. Notice that I cannot cannot add these together. This multiplication of 2 times this number must happen before we can add. or you can think of it as like terms. These two things are not like terms. This 2 has this log base 6 of x on it. So we cannot combine those together. Then let me do log base 6 of 6x over y squared. That's as simple as it can get, and yet it's in that expanded form. Here, first I see a quotient. I'm going to use that quotient rule first, where I do log base 6 of the numerator minus log base 6 of the denominator. Then notice in this argument I have a product. So now I have log base 6 of the first number plus log base 6 of the second number. Still subtracting, but here notice I have that power. I can use the power rule to multiply this 2 times my log base 6 of y. I'm almost finished, but here I can evaluate log base 6 of 6 to be 1. So I have 1 plus log base 6 of x minus 2 times log base 6 of y. I've expanded it using all the rules so that I only have one number in my argument each time, and none of them are raised to a power. And then I've simplified or evaluated everywhere that I could. Make it a little more difficult. Let's do log base 6 of, in my argument, let's have 6 times the square root of x over y squared. Notice that here it's really similar to this, but in this case I have an exponent on my x this time. Remember that we can write that square root with an exponent so that we have 6 times x to the 1/2 power. Raising it to the 1/2 power is the same as taking the square root. This means the same as that, over y squared. First, I'm going to use that quotient rule to separate the argument. So I have log base 6 of 6x to the 1/2 minus log base 6 of y squared. Then I'm going to use my product rule to separate the argument there. So I have log base 6 of 6 plus log base 6 of x to the 1/2 minus log base 6 of y squared. And then lastly, I can use that power rule and do some simplification. So log base 6 of 6 is just equal to 1. This power can come out front so that it's multiplying times the log, and this power can come out front so it's multiplying times that log. I have now expanded that. Notice that I did the quotient rule, then the product rule, and lastly the power rule. As we expand our logarithms, that's kind of what you want to look for, is that quotient rule, then the product rule, then the power rule each time. A couple of other little notes on this. Notice that I put parentheses around my argument here when I have an x times a y in there. Or in that bottom one, when I had a 6 times my x, let's make that a 6. Notice that that's equal to 1 plus that log base 6 of y, because I can simplify this. Now this is something different than if I don't use the parentheses. If I don't put the parentheses there, then in my argument is just this 6. So this says log base 6 of 6, which is just equal to 1 times that y. So we have to be really careful to put parentheses around the argument when there's more than one item in that argument, more than one number in your argument, because this means something different than that. So as you're working, you want to make sure that you're putting parentheses when you have more than one number in the argument. Here, though, we only have one number in the argument, so it's okay to leave those parentheses off. Let's do one last one where we're putting everything together, a little more difficult problem, and then we'll have used our properties to expand these logs. So here's log base 6 of 6 over x to the y fourth. Let's make it the square root of x times y to the 4th power. Again, the first one I'm going to look for each time is my quotient rule. So I'm going to use my quotient rule, log base 6 of the numerator minus log base 6 of my denominator. Again, the parentheses here are really important to show that both of those numbers are in my argument. Then I can go ahead and simplify this to be 1. Here I have a product, so I'm going to separate these by using my product rule, but I have to be careful because this negative is on this whole number. So to show that, I'm going to put a parentheses out front to show that this whole thing is being multiplied by that negative. So I have log base 6 of the first number plus log base 6 of that second number. So again, quotient rule was used first, and now I'm using the product rule. This I can distribute to both of those. So when I have a number that is in the denominator originally, it should have a negative number out front. Again, that just makes sense because the degree or the power on the number would be negative. Y to the negative 4th means 1 over y to the 4th. And since we're just dealing with negative numbers there, it makes sense then that that would be a negative number. So anytime it's in the denominator, it's going to end up with a negative out front or a minus out front. Then I can change the powers on here. This log base 6 of, we could rewrite that with an exponent. Remember that square root is written with the 1/2 power. And now I can use that power rule so that I have 1 minus 1/2 log base 6 of x minus this power rule says I can multiply those two together. Now I cannot combine these because again this multiplication has to happen first. 1/2 times whatever this number is has to occur before I can do this subtraction. So I have to leave it just like this. Or you can think of it as they're not like terms, so we can't combine the terms. Here we've expanded the logarithm again. So things you want to think about as you're expanding your logarithms, you want to look first for that quotient rule, and then once you've separated your numerator minus the log of your numerator minus the log of your denominator, then use the product rule so that when you have two numbers multiplying, you add the logs, and then use your power rule last to help you to simplify. Then look for any that you can evaluate to help you evaluate those. So there we have expanded logarithms. In the next video, we'll look to condense the logarithms. Math Made Simple at Simpson Math. Thanks for watching.